Okay, last thing, find the x and y intercepts that I could find in the final that I saw of his. Absolute value equations. Now, an absolute value equation is very similar to a parabola. Okay, it usually, instead of a U shape, it's a V shape. We didn't really graph them. So, again, you got your x and you got your y-intercept. You can't just rely on the calculator as much. It's easy to do, but you can't just think that the calculator is going to do everything for you. There's only one y-intercept, okay? Remember, absolute value is all about distance that a certain value is from 0. So, like, the absolute value of 7, you could be at 7 or -7, okay? Because on a number line, if I'm at 7, I'm 7 places from 0. If I'm at -7, I'm 7 slots from 0. Okay, as I've explained quite a bit. I've explained the concept of absolute value, but I've never had you like graph it on a coordinate plane. And I'm not going to start right here. Now again, there's only one y-intercept. So 0, and you go, just replace the x with 0, absolute value is 0 minus 3 minus 5. Now your calculator doesn't do absolute values, okay? You need to do the operation within, that's -3. And how many units is it from -3 to 0 on a number line? If you counted, you'd count 3. This always is positive, no matter what. This always comes out as positive. And then subtract 5. Now that y might not, but this little part here does. And that's -2. So that's your y-intercept. Pretty easy. Now the x-intercept is where I get some funny looks. All these have actually 2 x-intercepts, and you're about to see why. Okay. Because remember, there's always 2 possibilities to have a certain absolute value. Okay, that's why there's 2. So again, we replace our y with 0. Then you are going to make a table, and you're always going to use both sides. But before you know what that's equal to, you have to undo the operation outside. You got to add 5, and that's 5. So 5 equals the absolute value of x minus 3. Now, I know my absolute value is equal to 5, so I could be at +5 or -5, and then the rest is pretty academic. You're going to have 8 and -2. Okay, now the next one. So again, y-intercept, same way, there's only one of them. There's going to be 0 is x, so I replaced, to solve for y, x has to be removed and replaced with 0. Now that's 5. How many units is it from 5 to 0 on a number line? 5 again. Again, that number that you write down out of here is always positive. And then -2. 5 minus 2 is 3, so that's my y-intercept. Now again, there's always 2 x-intercepts because x is inside of an absolute value, and an absolute value of any particular value always has 2 possibilities, okay? So your y's are 0, both of them. And then 0 equals the absolute value of x plus 5 minus 2. Now you're going to make your table with x plus 5 equals and x plus 5 equals, but you have to undo that operation outside of your absolute value. So you're going to add 2 to 0. That's 2. Okay, so 2 equals the absolute value of x plus 5. So I can be at 2 or -2. So when I minus 5, that's -3. And when I minus 5, that's -7. It's similar to how you do the Q problems, maybe even a little bit easier, but I don't know. You're not really going to see a new variable come up. Okay, next one. This one here is kind of bizarre, the last one I have. So again, only one y-intercept, and you just remove the x and replace it with 0. So that's -3. Now how many units is it from -3 to 0? It's 3. And then 3 minus 12 is -9, so that is my y-intercept. Now again, there's two x-intercepts. And I remove my y from the equation with 0. The reason these are called intercepts because if you had to graph that point, you'd stay at 0, go down 9. You're on the y-axis. You would go left, right on these and stay at 0. In that case, you're on the x-axis. Okay, so I'm going to bring the expression x minus 3 into both sides because an absolute value has two possibilities, but I do have to add the 12. So 12 equals the absolute value x minus 3. So I now know that that expression could equal 12 or -12. So I add 3, I'm at 15. Add 3, I'm at -9. Okay. Okay, now this one ain't going to take long because you're going to see why here in a minute. Well, same as the other ones, except one thing happens. So y equals the absolute value is 0 plus 2 plus 6. So you're going to end up with 2. Absolute value of 2 is 2 plus 6 is 8. So that's your y-intercept. Now at the beginning, I think my x-intercept, again, there's two possibilities. And 0 equals the absolute value of x plus 2 plus 6. Okay, so x plus 2, x plus 2. But something happens here because the way to undo plus 6 would be to subtract 6. Well, there's a problem with that. -6 equals the absolute value of x plus 2. Is it possible to be -6 places from 0 on a number line? If you counted on a number line, do you ever count, like when you're counting things, do you count by negatives? No, you don't. So basically then, if I get my absolute value, undo the operations, and I have a negative, then there are no x-intercepts, okay? It does not cross the x-axis. And again, you're like, well, how's that possible? Well, here, don't draw this, just watch. Remember, we said these are V-shapes. Well, that's a V shape, and it crosses the y, but it never crosses the x. Okay?